actually is iridium, and why is its presence on Earth important? Well, covering the basics, it's a silvery metallic element with the atomic number of 77. Has a high melting point of nearly 2,500 degrees centigrade, and it's named after the Greek goddess Iris, who is represented by the rainbow, and rather fittingly, she's one of the gods of the sky, a messenger who can fly on iridescent wings faster than the wind. Now, iridium is very rare in the Earth's crust, with most of it being commercially produced in South Africa. Its value is on a par with gold, and it can be combined with platinum to enhance the strength of that metal. It can be used in other items from helicopter spark plugs to pen nibs. As well as iridium's high melting point, it is the most corrosive resistant metal, and these properties combine to make it a really useful substance, or at least they would if it wasn't so rare. It's this rarity where the story of iridium gets really odd. In the Earth's crust, it averages out to be about 2 parts per billion, but in iron meteorites this is generally around about 3 parts per million, sometimes even more. So iron meteorites have over 1,000 times the content of iridium than the Earth's crust. And even stony meteorites have over 100 times richer deposits of iridium than the Earth's crust. This seeming imbalance is basically one of distribution within the Earth, and as a system it's just at different locations. There's a greater concentration of iridium deeper within the Earth, especially at the core. Now, some of this iridium can be brought up from the lower depths through volcanic action, which is why South Africa is the key area for producing iridium, along with other substances of volcanic origin. There is, however, a concentration of iridium that is close to the surface of the Earth. As you dig down through the layers of the Earth's crust, it's basically like stepping back in time, so you go deeper and deeper. And when you reach a layer dating back to about 66 million years ago, there's a thin layer of clay which is very rich in iridium. And this layer also happens to be the boundary layer between the end of the Cretaceous period and the start of the Cenozoic era, starting with the Paleogene period. Or, to put it another way, this thin layer of clay represents the end of the age of the dinosaurs. This thin layer of iridium deposited all around the world leads to the conclusion that there was either a very large meteor which struck the Earth at that time, or alternatively a substantial amount of volcanic activity happened, or even the possibility of both of these events combining to lay down this deposit of iridium. The presence of this iridium-rich layer is one source of evidence for a meteor impact being the event which put pay to the age of the dinosaurs. Because of this link between iridium and meteors, the presence of an increased concentration of iridium in an area can confirm an impact, even if no visible trace of the impact remains, or even if the meteor disintegrated before impact, then an airburst occurred. The area around the burst point, again, will generally show an increased amount of iridium. So that's iridium, a noble metal that's not affected by high temperatures, acids, bases, or most other strong chemicals, and also can tell us a lot about Earth's history.